Discriminate. So I'll go back and forth between the two language things here. So nature of roots. The quadratic formula, when I use the entire quadratic formula, tells us where the x-intercepts are located. When I talk about the nature of roots, I'm talking about how many. So what are my options? We closed our eyes, we imagined it in chapter 3. What were my options? I could have how many roots? I could have 1, I could have 2, or I could have 0. It's a pink book. No, is it a pink book? It's purple. It's purple. Oh, I see purple right at the front. But it's... Maybe? No? Okay. There's an extra one right up at the front if you need it. Okay. So here's the thing. The discriminant, this under the root sign, is the discriminant in the quadratic formula. So that part, so if we use the entire quadratic formula, that will tell us where the x-intercepts are. But if I ask you for how many roots, you can do one of two things. You can find the vertex and then close your eyes and imagine if it opens up or down, visualize that. But if it's not in vertex form, you could just use the stuff under the root sign to calculate how many x-intercepts we have. So if the stuff under the root sign comes out to be a positive, we're going to have two, answers isn't the right, we're going to have 2 x-intercepts. If we have a negative under the root sign, we will have no x-intercepts. And we ran into that yesterday when we were practicing with our quadratic formula. And if the stuff under the root sign is 0, we're going to have 1 root or 1 x-intercept. What's the other name? Roots, x-intercepts, and what's the other name? Zeros of the function. X-intercepts have 3 different names. Okay, so if you're asked for how many roots, just use the stuff under the square root sign. So if the question doesn't ask where they are, it asks how many. You can find your vertex, visualize if you want to, but when it's given in standard form like this, sometimes it's just easier to use the discriminant that's under the root sign. So the stuff under the root sign is called the discriminant, and so that would just be our b squared minus 4ac. It's inside the quadratic formula. And some people use the quadratic formula fully to answer the question, and that's fine too. So if I ask you to describe the nature of roots, that's asking how many roots we have, how many x-intercepts. So again, I'm just going to use my a is 1, b is -6, c is a +7. So I'm just going to use my discriminant to answer this question. Because if I didn't, I'd have to find my vertex, that'd be -b/2a, then I have to sub it into the equation to find the y-coordinate of the vertex, and I got to do some more math. So if I'm going to do math anyway, I might as well just use my discriminant. (36 minus 28). 8? Mental math there, folks. Does it really matter what the number is? What matters? That it's positive. Because it's a positive number, we know that we have 2 x-intercepts. And so how many roots do we have? We have 2 roots, or we have 2 x-intercepts. It's easy as that. It's just taking a little piece of that quadratic formula, and we're going to do some math with it to figure out how many roots we have. So this is going to be on the test. It's not going to be on the quiz. Okay. Ooh. This one's on the test, and nobody likes it. But I'm telling you, this question is on the test. No one likes it because it gets confusing. Okay, here we go. We know that A is 1, we know that B is 8, and we know that C is some value of M. I don't know what it is. But what we do know is that it has 2 real roots. So what do we know the discriminant has to be? Has to be positive. So the way we're going to write that is B squared minus 4AC is greater than 0. Because any value greater than 0 is going to be positive, correct? A lot of people have a really hard time with that. What if it was only 1 root? What would that change to? Equal to 0. And if it had no roots, it would be less than, right? This is less than 0 because that would be a negative number. So this tells us so we know that the discriminant is greater than 0. So that means that we're going to end up with a positive number. So all we're going to do is substitute the stuff in that we know. I know I got 8 squared minus 4 times 1 times m is greater than 0. Now you guys solved for inequalities in grade 9. Did we graph them in grade 10? I don't know if we did. I didn't teach grade 10 this year, I taught grade 9. So I know we did this stuff in grade 9, but we're going to solve this inequality. And it's just like an equation. It's just like an equation. So I want to isolate the m, that's what I'm trying to do. Okay. So I'm dividing both sides by -4. If you divide by a negative coefficient, what do you have to do? You'll be a hero if you've remembered this from grade 9. Okay, that makes me feel better because sometimes I forget to do it. If you're dividing by a negative coefficient, you have to flip the inequality. So the big end was pointing at the end, so that means the little end is pointing now. And -64 divided by 4. Or -64 divided by -4. Anybody? 16? Should be positive 16, right? So we know that m has to be less than 16. Okay, so let's just make a little note here. If dividing and if it's a positive, you don't worry about flipping it. It's only if it's a negative coefficient. And that's why nobody remembers it because it's a really specific, really specific thing. I just did this in my calculus class now that I just recorded a video yesterday on inequalities. And it was essentially this. Okay, describe the roots of this one. Or sorry, describe the nature of roots. So again, that's just asking me how many. And before I can do anything, before I can pick my A, B, and C, it has to be equal to 0. So I have to add 9 to both sides. So I'm going to have 3x squared minus 5x plus 9 equals 0. So I have to have it equal to 0 before I can do my quadratic formula, before I can do my discriminant. So my A is 3, my B is -5, and my C is a positive 9. So I'm just using my discriminant here. And I'm trying to figure out whether it's going to be 0, negative, or positive. That's really what I'm trying to do. So I'm going to have -5 squared minus 4 times 3 times 9. Holy Hannah, that's going to be a big number. 12 times 9, 108. 12 times 9, 108. Okay, do I need to finish this? Do I actually need to know what that number is? I don't, what do I need to know? What is my answer going to be? It's going to be negative. And so what does that tell us? No roots. No x-intercepts. I'm just going to write it like that. Okay, so I got to stress to you that you need to have this. This is the answer. Like, that's the important thing. It's okay to tell me that that's negative, figure it out, what's the negative number, but it's this. I need to know that you understand the connection between that a negative number under the root sign means that we're going to have no x-intercepts. Okay, that was it. Fast lesson, 10 minutes and 45 seconds. You guys have a quiz tomorrow.